Hey guys, and welcome to the Web3 tutorial. In this video, we're going to be building a UI or front end to interact with a Solidity smart contract on the Ethereum blockchain. We'll use the Web3 library to get data from the blockchain and be able to display that data in our front end applications, and also send transactions to the blockchain from our UI. We're going to start from scratch and work through every step of the process so that you have a complete understanding of how to write front end code for your smart contracts. When we're finished, we'll end up with a fully functional dApp, or decentralized application, running on the Ethereum blockchain. So if that sounds good, stick around and let's get started. Alright guys, so before we get started, I just want to give you a brief overview of what we're going to be doing in this tutorial. Let's take a quick look at a roadmap. First, we're going to be creating a NextJS app as the front end of our web application. We'll create a new page, get some basic HTML and CSS in place, nothing too fancy, just enough to give us some structure to work within. Next, we'll install the Web3js library. Web3 is a library that allows us to interact with our Solidity smart contracts on the blockchain and call methods on them from the JavaScript in our front-end application. But more on that later. After that, we'll set up a basic Connect Wallet button with functionality to allow us to connect our MetaMask wallet to the website. Before we can do much more, we'll need a smart contract out on the blockchain that we can interact with. So we'll use the Vending Machine contract from one of my previous videos. I won't go into too much detail on the Solidity side of things here since we've covered that in detail before. By the way, there's a link to that video in the description if you want to check that out in more detail. However, we will create a new Truffle project, configure it, and deploy our contract to the Ethereum Rinkeby testnet. Finally, we'll return to our front-end application and use the Web3 library to create an instance of our Solidity smart contract in JavaScript so that we can call methods on it and interact with it directly on the blockchain from our UI. Alright guys, so let's start building out the front end for our application. Now, the one prerequisite here is that you'll need to have Node.js installed on your system. So if you don't, just head on over to nodejs.org and choose your operating system and go ahead and download the installer and get that installed. And after that, let's go ahead and move to the workspace that you want to work into. And let's open up a terminal. And so we are going to be building our front end using the NextJS framework. NextJS is an open source framework built on top of Node. It's specifically designed for use with React applications, so it's kind of like a framework for a framework. And it's just what I have been using lately to start all of my front-end projects. Comes with a lot of great stuff just out of the box, like server-side rendering, static page rendering, and routing. So it just kind of comes with a nice clean package, and I find it to be a good starting point for most of my apps. So once you're in your workspace and you go ahead and open up your terminal, okay, and then we're going to do npx create next app followed by the name that you want to give your app. So I'm going to say vending-machine-app and go ahead and hit enter. And so what this basically does is going to install the packages we need for Next, and it's going to create some folders, subfolders, and files, which will basically be the scaffolding for our front-end application. All right, and if you're running into any problems at this point, for example, if your console is saying npx not found or not recognized, then you probably just have installed Node and you'll need to reboot your machine, then come back to this point and try it again, and then hopefully it should be working for you. All right, guys, so once that's complete, we can take a look and see the new folder that's been created for us, and let's go ahead and cd into that Vending Machine app folder. All right, now all the packages have been installed for us as part of the install process, so we can go ahead and run our application. So I'm going to do npm run dev in order to run it in dev mode so we don't have to worry about a build. So go ahead and hit enter, and then we should be able to see our application on localhost 3000. And there we go. So there is our placeholder text, our boilerplate code, everything is ready to go. And we can start by creating new pages and start to create our own content here. All right, so I'm going to go ahead and open up Visual Code and open up our project. All right, so in order to make a new page, the way that Next works is there's a Pages folder here, and every file inside that Pages folder, we can take a look at index here, it's basically a functional component that represents a page. And so index represents just the slash route, but any new page we make in here, the file name of that JS file will be mapped to a route in our site without any further configuration. So it's pretty convenient. So what I'm going to do is go ahead and make a new file, and I'm going to call it vending-machine.js. All right, and so let's just try to make some code changes here and see them reflected in the site. So I'm going to create a new function. I'm going to say export default function vending machine. And then inside this function, we can return some JSX. So I'll say return. We'll do it h1, and we'll say vending machine. All right, let's go ahead and save that. And let's go back to our browser and go ahead and type in your browser URL window /vending machine. Yeah, so as you can see, it was pretty easy for us to stand up a page here with NextJS, and we'll go ahead and continue to work on building out this page for the rest of the project. All right, so let's just work on tweaking our HTML and CSS a bit until we have something that we're happy enough with to continue on our project. So let's go to the styles folder and expand that. What I'm going to do is copy the file for the home page, or I'm just going to create a new file, I think. So I'm going to go to the root level, create a new file, and I'm going to call it vendingmachine.module.css. So by default, our project is set up to use CSS modules. I think that's fine for now. We'll just go with that, and then we can go back to our vending machine, and above our code, we'll go ahead and import that. So I'll say import styles from, and then go back up one level, reference the styles folder, and then there's my IntelliSense. Save me a few keystrokes there. .module.css. Okay, so now we've got that imported. So a place, just in case we need a place to add some additional CSS. All right, so other than that, though, we're going to use a CSS library called Bulma, which I've used on several projects, and I just like it because it's super simple, intuitive, and it's just real easy to get some CSS up and running quickly. So I'll go back to the terminal. I'll go ahead and do Control-C to stop the app, and I'm going to do npm i Bulma. Okay, and that'll install all of the Bulma CSS packages for us into Node modules. Great. And then I'm going to go ahead and import Bulma-css-bulma.css. Okay, so that'll make it easy for us to get some good looking UI up and going pretty quickly. All right, so next I'm going to borrow a few things from our index page. So if you flip over to the index.js under pages, I'm going to take the head component and borrow that. And this is something that's specific to NextJS, and what it does is it allows us to write things that you would normally find in the head section of the HTML document directly in our component without having to go to index.html like you would with a more normal React application. So I'll go ahead and grab that head section starting on line 8 from index.js. And for now, I'll just put it right above that h1. We're going to rework a lot of this in just a few seconds here. So I'm going to say, vending machine app, and we can get rid of the link for the favicon. We don't need that. And let's just say a blockchain vending machine app for the description. Go ahead and save that. Great. Okay, right, so we've got to have one parent element here. So let's go ahead and create a wrapping div element for all of our HTML here. And closing tag, and we'll just indent that a little bit right here. All right, so next we'll start to build out some structure for our page. So at the top, we'll have the vending machine, the logo, or just like a H1 tag, and then we'll have the wallet connect button sort of on the right-hand side. And then underneath that, we'll just build out sections for the rest of our UI. So I'll start with a navbar element, and this has got to have a class name of navbar. And just bear with me here, this is probably going to be quite a bit of typing, probably the most typing of the course, just to get this HTML skeleton in place. But after that, it shouldn't be so bad. All right, so inside of this, I'm going to use a div class name container. And the container class is coming from Bulma. It just provides kind of some spacing and padding and margin and things like that to nicely divide up the layout of the page. Okay, I'm going to have another div inside of this one. Class name equals navbar brand. Again, this is another Bulma thing, and this is usually where like the company logo kind of lives, and it just provides some structure for it. So inside here, we can do our H1 tag. And we'll just say vending machine. You can call it whatever you want, blockchain vending machine. I'm just going to keep it simple here. All right, and then we can do a navbar end section on the same level as the brand. So we can just copy this, try to save a few keystrokes here. So I'll do navbar end, and that'll just place this section at the right-hand side of the page on the navbar. So that's typically a good spot for like a, connect wallet button. So I'll do button and another Bulma class here. We'll say button. This is pretty common to most CSS frameworks. And then they have a isPrimary class, which will give it a nice green color. All right, so for the text, we'll say connect wallet. And do we have a close tag for the nav? Oh, sorry, this should be nav, not navbar. I got that mixed up with the class name. So make sure that the element is nav and the class is navbar. All right, let's save that and just see what we've got so far. So we go back to our page here. Oh, I've got to restart mine since I installed a few things. So I'm going to do npm run dev. There we go. Okay. Hey, at least that's something. That's a start. So we'll continue to style this and kind of add some more structure to it because I think it's a little bit too wide, and of course we want this. This doesn't really look like an H1. Bulma has some resets, I think, that reset all of the H tags to like normal size text. So let's go ahead and fix that now. So we can go over to our vending machine modules. And if we look at the home modules, it's using like a main class for the outermost wrapper. So let's keep consistent with that. And we'll say class name. Now this time, since we're using classes from our module CSS, we're importing it as styles, right? So we have to do styles dot and then the class name. So I'll say main, save that. I'll come back over to our module CSS, and then we're going to do dot main. And let's fix that H1 tag first. So let's say font family. Just pick whichever one you want. I'll do Arial, Helvetica, that family. And then let's do a font size. We want that to be a little bit bigger. So I'm going to do 2EM, and let's make it bold. So I'll say font weight equals bold. All right, save that, and let's see how that looks. Good, better already. So I think one thing we could do maybe is add just a bit of padding above and below our nav bar here. So we can actually do that right in our component, and we can use Bulma's atomic CSS helper styles to just as a quick way to give us some padding options here. So I'll do MT, which stands for margin top 4, and I'll do margin MB for margin bottom also is 4. Let's check that again. There we go. A little bit more breathing room here. Okay, cool. So at least that gives us a nice page header. And so I kind of imagine that here's the Connect Wallet button. We click on that to connect to MetaMask. And then sort of our UI for interacting with the smart contract is going to be down here in the body. So let's just add some placeholder text for now to represent that. So I'm going to go just directly below the nav element, and let's add a section, which is sort of just a semantic, dividing mechanism. Underneath that, we'll do a div. We'll say class name equals container. Again, that's just a Bulma sort of convention to give us some spacing and padding. And then inside that, we'll just do, let's just say placeholder text. All right, let's see how that looks. All right, perfect. Good enough for now. All right, guys, so the next thing I think we're going to tackle is wiring up the Connect Wallet button so that we can connect our MetaMask wallet with our application. All right, so Web3, basically, I just wanted to show you quickly the documentation. So Web3js read the docs.io. Everything is really well documented, so definitely use this as a reference. I'm not going to even attempt to go through everything here, but just point out a few things we'll be using. Basically, you install the Web3 package and then you get access to all these things, or you could install them individually, depending on your needs. So two that I'll point out that we're going to be using are going to be Web3 ETH, and we're going to be using that to get the list of accounts from MetaMask. And we're also going to be using Web3 ETH.contract in order to create a local copy of our Solidity smart contract. So let's go back over to our terminal. We can do Control-C to stop our application. And let's do npm I web3. All right, great. Looks like that's complete. So the next thing I'm going to do is go back to my code editor and just go ahead and import that onto the page. So I'll go below our head import, and I'll say import Web3 with a capital W from Web3, and go ahead and save the file. Okay, so our next goal is to wire up some functionality so that when a user comes and clicks on the button, MetaMask opens up and asks them if they want to connect. So the way we can do that, the MetaMask API provides something called the Ethereum Provider API, and it's basically a global object that's injected into window. So it looks like this, window.ethereum. And this is essentially a provider API that allows us to request accounts from MetaMask. It allows users to sign messages and transactions, and allows us to read data from the blockchain the user is connected to. So first, before we even attempt to do that, let's just set up a sort of generic click handler for the button and just get that working first. All right, so I'm going to go right above my return statement, and let's do, so this will be a click handler. We'll call it Connect Wallet Handler. All right, and I'm going to use an arrow function here. And in fact, I'm going to do a bit of refactoring at the top level and make this an arrow function as well. So we've got a function expression right now. I want to change this to a arrow function assigned to a variable, just to sort of, keep the style consistent here. So I'll change that to an arrow function, and then at the bottom I'll export Vending Machine. So we'll just come right down here below line 36, and I'll do export default Vending Machine. There we go. All right, so let's wire this up to the button. So I'll say on click, capital C for the click, and inside some curly braces, all I have to do is pass the name of our handler function. All right, so let's just, I'll tell you what, let's do an old school alert, and we'll say connect wallet. So let's just make sure that at least this much is working. So I'm going to save the file, go back to the UI, and let's just try that out. And there's our alert. So it looks like our click handler is set up just fine. All right, let's go back to the code editor. Okay, so the one thing about window Ethereum is that this object is only going to exist if the user has MetaMask installed. So we just need to write a little bit of code to detect that. And if it's not installed, maybe output a message saying, please install MetaMask. So let's do an if statement. I'm going to say if type of window is not equal to undefined, and these should be equals. Type of window.Ethereum is not equal to undefined. So if this condition is met, basically they have MetaMask installed, and we can proceed with what we want to do. And so we'll say else, meaning they don't have, let's say MetaMask not installed. Then let's just console log an error for now, and we'll say please install MetaMask. All right. So if we do have MetaMask installed, we can go ahead and use window.Ethereum. So I'll say window.Ethereum. And what we want to do first is request the accounts. So that's what's going to basically force MetaMask to open up and ask if we want to connect our MetaMask to the website. So we'll say window.Ethereum.request. And then this is just some pretty specific syntax that say method, and then in quotes, eth_request accounts. Very specific syntax to the Ethereum provider API. Ethereum does not exist. Window. Okay, I may have a mistake here, but I'm not seeing it right now. Okay, we'll ignore that for now. All right, so now after that, what we want to do is we can also use window Ethereum to instantiate our Web3 instance, which we can then in turn use to call methods on our Solidity contracts. Now there are a few more steps in between, but the first thing we want to do is actually declare a new variable for Web3, not to be confused with the import of our actual Web3 library. So I'll say Web3 equals new. So this is a constructor function, new Web3. And as an argument, it takes window.Ethereum, which is the provider API. Okay, let's go ahead and try that. Save the file, and let's see what happens here. I'm going to open up my console log in case we have some errors here. Okay, so far so good. So as you can see, MetaMask is opening up, and it's asking us if we want to connect. Okay. And there we go. So we are now connected to the site. Let's open up MetaMask again, and let's see what happens if we reject the connection request. So the way I can do that is, let's see, how do I disconnect? There we go, disconnect this account. Okay, so now we're no longer connected. Let's refresh the page, or I may not have to even do that. But just to make sure here, now let's try it again. So again, we're prompted to connect to this site. I'm going to say cancel this time. So as you can see, we get some errors here. Uncaught promise, and that's a clue that we may need a little more structure around our request. So let's try putting that in a try catch, and we'll use async await. So a little bit of refactoring here. The first thing we want to do is make this function async. Okay, and then underneath our if statement, we'll create a try catch. Okay, so we'll copy these two statements and we'll put these in our try. Now this is going to be an await. All right, and then underneath that, we'll do our catch statement. Give it some curly braces, and then let's say console.log error.message. All right, let's save it and see if this works. Okay, I'll clear that, and let's go ahead and connect. Great, so our wallet still opens. We haven't broken anything. And cancel. Okay, and great. So we're logging our error message. So far so good. Let's go back to our code editor. All right, so what next? We could take it a step further and actually output that error message on the screen. So not in the console, but actually on the web page. So let's go ahead and do that. So we're going to use hooks. Let's go ahead to the top of our file and import useState. And we'll create a state variable for our error messaging. So we'll say from React. Okay. And I'll go right below Vending Machine, and I'll make an error variable. And then I'll add our set error function. And this is going to be use state, and we'll initialize it with the empty string like so. All right, and I can get rid of this comment for now. Okay, so we need some HTML now to output our error messaging. So I think I'm going to copy this last section here. And again, we can start to use some Bulma classes. So for errors and things like that, we can do container, and we can add the has danger or has text danger property. I love that name, has text danger. All right, and in here we can simply replace the placeholder text with our error variable from our state. Go ahead and save that. Now, the last thing we have to do is, instead of console logging this, we'll call our set error from our useState hook. So we'll just replace, oops, wrong one. Make sure you're up here in the try catch. All right, go ahead and save, and let's try that. So I'm going to clear this. I'm going to do connect wallet, and I'm going to refuse the connection. And great, now we see our error messaging on page. So that's a nice improvement over what we had before. All right, so I think we're good on our UI for now. And in the next section, what we're going to have to do is we're going to pivot to our vending machine smart contract. And we're going to have to go through the steps to actually get that contract deployed out to the Ethereum testnet, so that we could then come back to our UI application and start to call some methods and interact with our smart contract. But first we need to get it out to the blockchain. So let's focus on that next. All right, guys, so the next thing we're going to have to do here is to create a new project for our vending machine smart contract so that we can deploy it out to the Ethereum blockchain. We'll be deploying to the Rinkeby test network. To do that, we'll be using Truffle, which is a smart contract development environment that makes it easy to test and deploy smart contracts. Now, I'll be moving pretty quickly through this section since I've already covered this in more detail in the smart contract testing and deployment guide video, but you still will be able to see every step. So, all right, with that said, I'm going to go back up to sort of outside of the root level of my front-end app, and I'm going to create a new folder. So I'm going to do make directory, let's call this one Vending Machine. Same as the other one, except without the app suffix there. All right, and once that's done, let's go ahead and change directory into that folder. Okay, and let's do a npm init. This will initialize an npm project for us. So I'm just going to go ahead and accept all the defaults here. All right, perfect. So we'll need to install Truffle as a global package if you don't have it already. So if you don't have it, you do npm I for install -g for global Truffle, just like that. I'm not going to run this myself since I already have this, but that should install Truffle so that you'll then be able to access it from the command line. So once you've done that, we can do Truffle init to initialize a new Truffle project. Okay, great. that looks like it installed perfectly. Now there's a couple of other things I just want to go ahead and install while we're here that I know we're going to need. So let's do npm i.env because we're going to create a .env file to hold some of our variables such as our account address and our Infura API key. And then let's do a Truffle-hd wallet provider. Wallet-provider. And we'll need this for our testnet Ethereum configuration. In other words, we're configuring Truffle to point to one environment or another. And we'll go over this in just a few minutes. So I'll go ahead and let that install. I'll stop the video until this is done. All right, great. So it looks like that is now complete. So let's, I'll tell you what, let's go back to our code editor and I'll close up the front-end app for now. And let's take a look at the scaffolding that, or the new files and folders that the scaffolding has provided for us. So we're going to have to make a bunch of changes here and configuration setup kind of tasks. So I'm going to go ahead and close out all of these files. And the first thing we're going to do is, let's see, copy our smart contract into the contracts folder. So as I mentioned earlier, we're going to be reusing the vending machine contract from another tutorial from my YouTube channel. So let's go ahead and I'll provide a link to my GitHub page here, but I'm just going to navigate to it right here. And we're going to grab that code. We're going to basically create a new .sol file and just copy that code directly into our new project. So again, I will provide this link for you guys, but I'm just sort of navigating to it here. And I'm literally just going to copy and paste this code. Okay, back over to the code editor. I'm going to make a new file under the contracts folder, and I'm going to call that vending machine.sol, and I'm just going to copy that code directly into this file. Perfect. Save that, Control Save, and we're done. Done with that step. Now the next thing we need to do, we need to open up the migrations file, and we need to create a new migration file so that our vending machine smart contract is picked up when we migrate, or in other words, deploy out to the blockchain. So what I'm going to do is simply copy the existing file. Now you might notice there's an existing migration smart contract. That is just a smart contract that Truffle has provided for us by default to keep track of all of our deployments to the blockchain. So you can kind of ignore it for now. We're not going to use it in this tutorial at all. All right, and wow, that's taking a long time to copy. Okay, let's go ahead and rename that file. And we'll call it to_vending_machine_migration. Perfect. Now all we need to do is copy the contents from the initial migration file into our new file. Oh, it's already there because I copied the entire file. Forgot about that. And let's just change the name to vending machine. Everywhere where we see migrations should be 3 spots. There we go. Control Save, and we're done with that. So now that whenever we run our migration command, Truffle will pick up our new file, our new smart contract. Okay, perfect. All right, moving along. The next thing we want to do is create a .env file. So let's go up to the root level, create a new file, and let's do .env. Perfect. All right, now there's a couple of things. We just need 2 values here, really. So let's say private_key_1 equals, and the other one is going to be Infura API key. Infura_API_key, and save that for now. We'll grab these values in just a second. So moving along, next thing we're going to do is open up our Truffle config.js, which should be in the root folder. All right, and we just need to make a couple of changes to this file. So at the very top, let's require .env. So we'll say require .env.config. Okay, and this is just some some wiring up so that we can read these .env variables in this file. All right, and the next thing we're going to do is create a new variable for HD wallet provider. Require at Truffle / HD wallet dash provider. Okay, and you'll see how this is going to be used in just a second. All right, so that's all we need there for now. Now what we want to do next is set up a config block for the Rinkeby test network. So if you scroll down just a little bit to the networks property, you'll see a bunch of commented out code. You see about on line 62 or so, there is a commented out config for Ropsten. Let's go just above that and we'll create our Rinkeby configuration. So I'm going to say Rinkeby and set that to an object. And don't forget to add a comma after that. Okay, so I'll say provider arrow function new, new HD wallet provider. Okay. And so this is where we're going to pass in our keys, our Infura URL, and one other parameter, which is the number of addresses. So I'm going to say private keys, and this has to be an array. So we're going to say process.env.private_key_1. And remember, that references the variable that we're going to set in our .env file. I've got some spelling there to fix. All right, so now we're going to do provider or URL. All right, and this is going to be basically, we're going to have to grab this URL from Infura. And Infura basically is a service that allows us to connect to Ethereum nodes. All right, so we'll grab that in just a minute. We'll just leave that blank for now. And then number of addresses. I think for this app we just need one. So we'll leave that as 1 for now. All right, a couple of more properties under provider. So we'll give it a network ID. And you can kind of see where I'm coming from here. There, you've got the commented out Ropsten configuration, and some of these values are going to look really similar. So network_ID for Rinkeby, it's going to be 4. For gas, we'll just use the default, which is 55 and 5 zeros. Confirmations 2. And here I'm just sort of starting to copy some of the values from our default configs here. And skip dry run true. All right, great. So we need to fill in a couple of blanks here, the provider or URL. So if you haven't set up an Infura account yet, I encourage you to go out to infura.io and go through the motions to sign up for a new account. In my case, I've got one, so I'm just going to log in. But as soon as you do that account sign up, then you'll be able to come in here to your dashboard and create a new project. Again, I've already created my project here for Vending Machine. So once you've created a new project, you can go ahead and click on it and go ahead and navigate to project settings. And here is where you can go ahead and grab your endpoints. So just make sure that you're on Ethereum, you're on Rinkeby instead of mainnet. And go ahead and copy the first URL, the one that starts with HTTPS. All right, endpoint copied. So let's go back to our code editor. Let's go back to our .env file. And I'll tell you what, I'm going to change this to URL instead of key. We're just going to copy the whole thing, make it a little bit easier. So then here I just have to use a process.env. Where is it? I'm not seeing it. So I'm just going to go ahead and copy it from my .env file, Infura API URL, and go ahead and copy that right here. Okay, excellent. So the final thing that we need to grab is our, and I need to change the spelling here, private key 1. So we need to export the private key from our wallet. And the way we can do that is go ahead and open up MetaMask and go ahead and select the account that you're going to be working with and select the 3 sort of dots here and go ahead and select account details. And we're going to do export private key. It's going to prompt you for your password. And of course, guys, this is something that you never want to share or make publicly available. This is just a test account for me, so I'm probably going to delete it after this video. So that's why there's no security concern here. But go ahead and copy that and paste it back into your .env file and save the file. All right, perfect. So yeah, thanks for bearing with me here. I know that's a lot of configuration, a lot of typing and kind of back and forth, but just the necessary wiring up that we need to do in order to deploy our smart contract. Finally, we can come down to our compiler and just update the version to 0.8.11 to match what we have in our smart contract. All right, I think that is looking good, and I think we're actually ready to run our deployment. So let's go back to our terminal, and we can run Truffle migrate, add a network flag, and network will be Rinkeby. And if we've done everything correctly up till this point, then we should be getting a message confirming our deployment to the Rinkeby testnet. And that deployment may take a few minutes, so I'm going to go ahead and pause the video here and come back once it's completed. All right, and that deployment did go through. It was successful. So what I'm going to do is go and make sure I'm under the to vending machine migration.js logging. And I'm going to go ahead and look for contract address. And let's copy and paste that. Just copy it to a notepad or anywhere where you have access to it for the next section, because we'll need this once we go back to the UI and continue our development there. All right, guys, so one more thing before we get back to our front-end Web3 development. Now, if you don't have MetaMask installed, you're going to want to go to metamask.io and just download it. It's a browser extension. It's a pretty quick install. You'll just download it, and I've already got it installed, but you choose your operating system and you install it for Chrome, and it'll pretty much install it in your browser, and then you can go to extensions and make sure it's pinned so that you always kind of have it available right up here. So once you've got MetaMask installed, then the next thing is you'll need some test ether in order to test out the smart contract, Web3, talking to the smart contract in the Rinkeby testnet. So the way you can do that is you want to navigate to faucet.rinkeby.io, and here where you can request some test ether. Now, it's a little bit strange what you have to do here, but you have to have some sort of social media like Twitter, Facebook, or something similar to that. And what you're going to have to do is create a post with your account ID that you want the test ether sent to. So I'll just show you an example of that. I'm going to go down here and copy to clipboard. This is just my public account number, so it's not my private key. Definitely don't get those two mixed up. And so I'm going to paste that here and simply create a tweet with my account number. Now, you can delete this afterwards if you want to, but what I'm going to do for now is I'm going to actually click on that tweet and copy the link, the direct link to this tweet. Then I'm going to come back over to the Rinkeby faucet and paste that in there, and then I can request my ether. And I usually choose the 18. They blacklist you for 3 days just so you can't repeatedly request more. Insufficient funds for gas times price. Oh, that's strange. I've never seen that error before. Let me try that again. Try a different amount. This faucet it's usually pretty reliable, but sometimes it tends to break frequently or not be online. I think there are just a lot more people developing these days. But These are the correct steps, so give it a try, and I'm not sure why it's not working for me right now. But what happens is basically it takes just a couple of minutes, and then you'll see that those 18 Ether reflected in your account 1. So hopefully that's working for you guys. If not, let me know in the comments. I think maybe there's just something kind of weird going on right now, because this usually works pretty easily. So anyway, you're going to want to make sure that you've got some test Ether in your wallet before we go to the next section. All right, guys, so let's go back over to the code editor and continue working on the Web3 part of our front end. Okay, so as I said before, we'll be using the Web3 library, which we've already installed in our NextJS app, in order to communicate with our smart contract on the blockchain. So the way this is going to work is we're going to initialize a new instance of Web3, and we can call a contracts function on the ETH library inside Web3 to basically create a new copy of our Solidity contract, a local copy of our Solidity contract for the front end to use. Now, in order to do that, we're going to have to pass in something called an ABI. That stands for Application Binary Interface. And the ABI, it's basically a JSON representation of all of the inputs and functions and methods on our Solidity smart contract. And you can think of the ABI as sort of your passport between the Ethereum world and the JavaScript world. So the JavaScript runtime will need to know in advance, which methods are available on the smart contract that it's calling over on the blockchain. So that's a simple explanation of this. And what we're going to need to do is, first of all, let's create a new folder under Vending Machine app, under the front end side of our application. And let's call it blockchain. Okay, and this will hold everything relating to the blockchain side of things. Now inside that folder again, I'm going to make another new folder. I'm going to call it contracts. Okay, so now what I'm going to do is I'm going to go back into the smart contract folder, and I'm going to copy the vending machine smart contract, and we're going to paste it in our front end app under blockchain contracts, the new folder that we just created. So go ahead and paste that in there. All right, now, so basically what we need to do is we need to compile this contract locally in order to generate the ABI, which we can then use to initialize a new version of our smart contract locally, basically. So to do that, we need to download a command line compiler called solc. So I'm going to do npm i solc for Solidity compiler. And what we'll do here is we'll create a new script in package.json in order to run this. Okay, it looks like that installed correctly. All right, so we need one more folder under blockchain. So go back up to blockchain, and we need a build folder basically for the output of our compiled script. So I'm going to do build. There we go. So your structure should look just like this, blockchain, and then inside that you'll have your build and contracts folders. And inside contracts, you'll have vendingmachine.sol. Okay, so let's write our script now. I'm going to pop open package.json. And under the scripts object, let's create a new entry. And I'm just going to say compile. And so here's the command line that we can use from that package that we just installed. solcjs --abi to indicate that we want an ABI as the output, --include -path, node underscore modules / base -path. There's a lot of typing. Sorry about that, but we need to do it. Dot space and then the path to our Solidity contract. So blockchain / contracts / vending machine.sol or whatever you named your smart contract. All right, one more thing. Flag output directory. So --output -dir. And then we'll say blockchain / build. All right, hope you got all that. Now let's go ahead and try to run this and see if we get an ABI output. in our build folder. So let's go back over here. Now we need to do npm run compile. Missing script compile. Let's see. Make sure I save this. Let me make sure I'm actually in the right. I'm in the wrong folder. So let me go up one level. Vending machine app, that's what I want. There we go. Let's try that one more time. npm run compile. Okay, so basically what this means is the solc version of the solc package that we installed doesn't match the version of our smart contract. So the way we're going to fix that is we're going to manually, let's just add an entry in package.json. So I'll say solc equals 0.8.11. There we go. And let's just go ahead and run install again. All right, and let's try to compile one more time. All right, beautiful. Looks like that ran with no errors. So let's go back and see if we have anything in our build folder here. All right, so if we pop open this new file here that's been added to the build folder, this is our ABI right here. And it's all kind of on one line, so it's not easy to read, but if you kind of scroll through, you can see the names of some of the functions in our smart contract and a lot of the argument and return types and all that kind of information, inputs, outputs. So this is what we'll use to instantiate Web3 and then create a local copy of our smart contract. All right, so the next thing we need to do is create a new file under blockchain. So let's do that. I'm going to create a new file, and I'm just going to call it vending.js. Now, the sole purpose of this file is going to be to export a local copy of our smart contract. So let's go ahead and write that out. We're going to do import web3 from web3. Okay, that's the only import we need. All right, so the next thing we're going to need is an HTTP provider. And this is basically so that Web3 knows which blockchain to target. So I'm going to say const provider equals new Web3, capital W, dot providers dot HTTP provider. Okay, and then we're going to need our Infura link for the Rinkeby testnet. So we should be able to find that in our other application, in our Solidity env file. Yeah, there we go. So let's just copy this URL directly and go back over to vending. And let's just go ahead and paste this in quotes. All right, perfect. So now below that, we'll say const web3, and this will be our web3 instance, new web3, and then we can pass in that provider. Okay, perfect. Now we need to create a variable for our ABI. So we'll say const, let's just say ABI equals, now we'll grab that ABI from, let's see, under blockchain build. Well, I've got that file open still. So you can basically copy the entire contents of this file, and we're going to go ahead and paste it right in here. Just like that. All right, so now we can go ahead and create a local copy of our contract. So I'm going to say const, let's call this VM contract, and we'll keep it short. And then we'll say new web3.eth.contract with a capital C, like that. All right, and we'll pass in the ABI as the first parameter. And for the second parameter, this is going to be a string, and here's where we want to paste our contract address that we pasted to Notepad earlier. Now this is the address of the smart contract that we deployed to the Rinkeby Ethereum testnet. All right, so go ahead and copy that. Come back to your editor and go ahead and paste that in there. We're almost done. And finally, I just want to export VM contract. So I'm going to say export default VM contract. And I guess you could do that all as one line if you wanted to, but I just like to keep things kind of very visible and obvious. All right, so I'm gonna, let's see, what does it not like here? Oh, let me just fix that spelling mistake there. All right, perfect. Okay, so I'll tell you what, let's take a quick look at our page and just to remind us what we have already. So I'm gonna, I don't know why I opened a new terminal, but anyway, npm run start. And let's see, yeah, I guess I had this up already, but anyway, let's clear things out here. So basically we've got a simple page. We've got a header, we've got a connect wallet button that's working. We wired that up already. Now let's sort of look at our contract and think about what do we actually want to show on our page here? Well, what would be useful? So let's see if let's take a look at the contract, the Solidity contract, which I've got right here under contracts. So our vending machine, basically it's very simple. It's got a certain amount of what we're calling donuts. It could be anything, bicycles, donuts, gloves, anything, trading cards. And so it might make sense to just like show the total inventory of the vending machine, like right here. Like vending machine has, X items. And then maybe under that we show how many items that we have, whoever's connected, whichever wallet is connected to the site at the given time. So we can sort of fetch that via this donut balances mapping. So remember, this is a mapping of wallet addresses to unsigned integers, which represents how many donuts a given user has. So other than that, the contract's pretty simple. There are only a couple of functions here. There's a restock function that's only available to the owner to add more to the inventory. And then there's a purchase function where we said that each donut is going to cost 2 Ether. They're very expensive and tasty donuts, apparently. So I think it would definitely make sense to have like a little text input and button so where we could purchase additional donuts and specify how many we wanted. And then we'd expect to see, the inventory of the vending machine go down by X number of donuts, and we'd expect to see our, personal supply of donuts incremented by X many donuts. So I think that's what we'll try to do here. That'll be our goal for this section. First we'll output, number 1, the inventory of the vending machine, 2, the amount of items that this user has that's currently connected, and then, a little user interface to purchase more items. All right, so let's go ahead and see how we can do that. All right, so step 1, let's create some HTML for the donut machine or the vending machine inventory. So let's see, we can use this placeholder text right here, basically. All right, let's change this to be a H2. Okay. And let's say vending machine inventory. And so to display the number of donuts in the machine, we'll create a new variable. We'll just call it inventory. Okay. All right, so now we actually need to create this and then create a method to actually call the smart contract to populate this variable. So let's do that next. I'm going to create a new state variable for inventory. So let's say const array brackets and inventory, and then we'll do a set inventory. We'll say use state, and we'll initialize it to empty string again. All right, so basically we want the page to load, and then we want to reach out to the smart contract, grab the inventory number, and then populate the variable. So to do that, what we can do in React is use the useEffect hook, which basically is a way to run any sort of logic once the components of the page have loaded. All right, so I'll go down right underneath our Web3 variable, and I'll say useEffect. Now this takes a function as an argument, so I'll write an arrow function right inside of useEffect. And so basically so what we need to do is create a function to actually fetch the inventory from the smart contract and then call that from inside useEffect. So we'll create a function and we'll call it, let's see, get inventory handler. Okay, and we'll define that in just a second, but for now we'll just create the invocation right there inside useEffect. All right, now let's continue to write out this function here. So we'll do arrow function, give it some curly braces. And so here's where the fun begins, when we'll actually get to use our Web3 instance to interact with our smart contract. So this function call is going to return an integer, so we can set up a variable to hold that value, and we'll just call that inventory. All right, now we'll say VM contract. By the way, we need to import that. So this is the instance of our Solidity smart contract that we created before. So let's go ahead and bring that in. Go right below Web3 here, and I'll say import VM contract from, and we need to go up a level and blockchain, and then it's we called it vending.js. So blockchain/vending should do the trick. Save that, and sorry, we're jumping around a bit here. Okay, so now that we've got our contract instance, we can say VM contract dot. Now there's an object under this contract instance called methods, and as you can probably guess, this is going to contain a reference to all of the different methods on our vending machine smart contract. So from here, we can directly call any of the methods in our smart contract. So let's take a peek at our Solidity file again and find the function that's going to return right here. This is going to return the inventory of the vending machine. So we can copy this function name and we can paste it directly right here. So we're doing VM contract.methods.get vending machine balance. All right, now we need to do one more thing. Now, basically, in the world of Solidity and Ethereum in general, there are two types of ways to call a function. One is a call and one is a send. And so whenever we basically read from the blockchain, we use call, and we don't have to send in any ether with that function call. But if we're invoking some kind of function that's actually going to write data to the blockchain, such as buy donuts, because that increments our donut count and it decrements the vending machine balance. So that's all data that's being written directly to the blockchain. In that case, we do have to send in ether with the function call. So that's called a send. So in this case, we're reading only, so we can just do call.call and curly braces just like that. All right. All right, and so finally, we'll call our set inventory back from our use state, and we'll set the value of our inventory variable, and we'll set it to inventory. Now that might be a little confusing, but just make sure you understand the distinction. This inventory refers to the local variable. It's scoped to this function. Okay, so it's not available outside of this function. And this is going to hold the return value from our call to the smart contract. And the outer inventory variable is the one that we defined with useState that we're going to then use in our UI to output that value. All right, so hopefully that makes sense. So let's go ahead and save the file and let's see if this is working. So let's go and we just have to refresh our page here. Can't resolve. Oh, I got a spelling error. Sorry about that, guys. Sometimes it's hard for me to type and talk at the same time, and that's when I run into mistakes here. Okay, blockchain. There we go. I do know how to spell blockchain. I'm sure of it. All right, let's try that again. Objects are not valid as a React child. Okay. So basically what this is saying is the error message is a bit misleading. But the problem, just because I've seen this so many times, is that this is an async method, but we haven't defined it as such. So let's make this an async function, and then we'll add our await keyword right here, right? Because this is a call out to the Ethereum blockchain. It's an asynchronous function, and we have really no guarantee when that's going to return or how long it's going to take. So let's try that again. And bam, there we go. There's our 100. So this data is coming directly from the Ethereum blockchain. So thanks to the Web3 library, we're able to invoke functions from our smart contract directly and display that in the UI. So far so good, looking good. All right, so next let's go back to our code editor, and we'll set up a similar type of wiring for our own donut balance. And it's almost 100% the same, maybe 90% the same. There's a few things different here. So I'll tell you what, we'll do it in the same order. Let's go ahead and create our HTML first. So I'm going to copy this whole section. I'm just going to paste it right below. And what should we call this? So this is going to be sort of my personal inventory in my wallet. Let's just say my donuts. Why not? All right, so we'll need a new state variable. And let's say my donut count. Makes sense to me. All right, go ahead and copy that because we're going to have to define it now. We've used it before we've defined it. All right, so there we go. Now we'll do our setter. And just to be consistent, we'll keep this like camel case. There we go. All right, and I'll say use state, and again, I'll initialize this to an empty string. Cool. All right, so the next thing we're going to do here, now this is going to work a little bit different because we're not going to use effect here, because first we have to connect the wallet before we can really be able to determine how many donuts that we have. So we can't run this as soon as the page loads. So we're going to have to sort of figure out a way to use our connect wallet handler to call this function. So I'll tell you what, let's create the function first and then we'll worry about that. So I'll say const, this is going to be a new function declaration, and let's say get my donut count handler. There, bit on the long side, but descriptive. So, all right, so we'll learn from our previous mistake and we'll make this async right away. And that looks good. All right, so this time we're actually going to need a specific account, right? Because we're looking for the donut count of not just the smart contract in general, but of my specific account that's currently connected to this web application. So we can use Web3 to get a list of accounts. And here's what that'll look like. Const accounts equals await web3.eth.get accounts. And so this is basically going to use MetaMask's API to retrieve a list of accounts in my MetaMask wallet. Okay, and it'll be an array, so we'll basically use the first one, like array at position 0, to represent the current account that's connected to the web app, if that makes sense. All right, so this is going to return a number as well. So I'm going to say const count equals await. All right, VM contract. Again, this is our contract instance locally to JavaScript. Again, we'll say methods. And so with the one that we previously used, get vending machine balance, we have an explicit function that returns that for us. However, in the case of my personal, donut inventory, we don't have such a function. However, remember, for all state variables that we defined, we automatically get a getter function for those. So I don't actually have to define it. I can use it straight away. So remember, the mapping is called donut balances. So that means that we also have a function called donut balances. So that's exactly what we'll use right here. All right, and so we'll say donut balances of, and remember, this is a mapping of addresses to units, so we'll pass in our address, our current address, and then this is going to return our number of donuts. All right, so remember, we've just got a list, an array of all of our addresses, so I can say accounts, square brackets, 0, at 0 position. All right, so again, ask yourself, is this going to be a call or a send? Is this writing data to the blockchain? Well, no, it's just a query. So again, we can use call, and that should work. So again, we'll use state setter, and this was set my donut count, right? Set my donut count to count. All right, so finally we need to find a place to actually invoke this function. So, the accounts aren't really going to be available as soon as the page loads, so that's why we're not using useEffect here. But what we can do is we can use the connect wallet handler, and inside our try, here's the code that's going to run, if this is successful. Basically the last line of code here. So let's do exactly that. We'll call get my donut, oops, spelling mistake, get my donut count handler at the end of our try catch, or at the end of our try phrase. So we know that's been successful, so now those accounts should be available to fetch. And I've got to correct my spelling mistake up here as well. There we go. Get my donut count handler. Okay. Cool. So let's go back to the page and see if that's working. Oh, another spelling mistake. Where did I do that? User state is not defined. Oh, use state. There we go. A lot of spelling mistakes today. All right, let's try that one more time. All right, that's more like it. So great, we're seeing 100 for inventory and we're seeing nothing for donuts, which is totally expected since we haven't connected our wallet. So let's go ahead and do that. And I'd expect this to be 0 right off the bat since we haven't purchased anything yet. So we'll go ahead and approve the connection. And there we go, there's our 0. Excellent. So this is all going according to plan so far. The next thing we're going to do is add a little input and button for purchasing donuts from the vending machine. So let's go ahead and flip over back to our code editor. And let's do the HTML first. So again, I'm going to copy and paste the last section to give us a starting point. All right, so we can delete everything in the container here, well, which is just this h2. But we're going to create some form elements here. So let's create a new div, and we'll say class name. And again, we'll use some Bulma specific constructs here. So we'll say field. This indicates a form field. And this is just really adding some spacing and structure and things like that. Okay, so inside of that one, create another element, and we'll do a label. Class name equals control. And then for the label, we'll say buy donuts. And oh, I'm sorry, that class name should not be control, it should be label. So label, class name, label. We want the control to be after that one. So we'll create another div element and we'll say class name again. And this time we'll say control. Okay. And again, this is just another Bulma convention for our sort of spacing around our text input. So inside our control div, then finally we'll say input. We'll say class name equals input. And then we'll say type equals text, which of course is just an HTML convention. And then we can define some placeholder text, the text that you sometimes see before you enter anything into a form field. So we'll say placeholder older equals enter amount. All right, and make sure you have a closing tag or make sure you close up that input element just like that. All right, so next we'll just need a button to go ahead and execute that purchase. So we've got a button for our connect wallet. Let's go ahead and borrow some code from line 57. I'm just going to highlight that button element, and I'm just going to come down here and paste it. Let's do it right below this control element that's wrapping our input. I think that's probably a good place for it. Button is primary. Okay, so let's just change the text to buy. And then let's go ahead and define the function that, or at least put a reference to the function that we're going to define for purchasing. And so we'll call it just buy donuts. Works for me. All right, cool. Let's go ahead and save that, and well, let's quickly define this function just so the compiler doesn't complain. I just want to view the page and make sure that what we've done looks okay. All right, so let's go. Let's see, we're doing, you know, let's keep with convention. Let's say buy donut handler, since we're calling all of our other handler functions with a handler suffix. So I'll just go right below my get donut count handler, and I'll say const. I'm going to paste buy donut handler, and I'm just going to define an empty function for now. All right, so let's go ahead and save that, and let's just verify. All right, so, you know, I think we need some more space, like above the label and above the buy button. So let's go back to our code editor, back down to our HTML. So again, we can use these sort of Bulma atomic classes to give us a little more structure here. So I'll tell you what, let's do a class name on the section. And we'll say mt-4 for margin top. Let's go ahead and do 5, mt-5. So that should give us some spacing between those, the two counts, like the inventory count and the personal inventory count and our buy button. And then we can just copy this whole thing, and let's put one on the button itself. So I'm just going to do a little bit of quick reformatting here to clean things up. Here we go. And then, oh, I've got a class name here already, so I'll just do MT. Let's do a 4 on this one. Let's see how that looks. Right, back to our page. Yeah, I think that looks much better. Maybe we don't even need that much above the buy button, so let's make it a 2. Save that. Yeah, I think that looks pretty good for a simple UI. All right, so next step, let's go ahead and flesh out our buy donuts function. All right, so basically the way this is going to work is we're going to set up a state variable to hold the amount number, and we'll use an onChange handler to set that variable whenever, you know, the user types in a new value into this form field. Then we'll have an onClick handler on the buy button, which I think we've already wired up, and so that will reference a function that will actually execute the purchase. All right, so let's go back over to our code editor, and let's go back towards the top here. All right, so yeah, we've got our buy donut handler. Let's go ahead and create a state variable to hold the number of donuts to buy. And this will represent, again, the user input. So I'll say, let's see, what are we going to call this? Let's say buy count and set buy count. All right, and again, we'll initialize that to, well, we'll initialize this one to 0 since it's, actually no, we'll use an empty string. Okay, so now let's go back down to where we have that input, and we'll say onChange equals, actually we need to do curly braces here because we're going to reference a function, JavaScript. All right, so basically we're going to actually need to reference the value of this input and pass that to our change handler. All right, so let's go ahead and define a function for updating the donut quantity. So we'll just add a reference to that here. Let's say update donut quantity. And I'll go ahead and copy that, and let's go ahead and define the function up at the top. All right, I'll put this one right above the buy donut handler. So we'll say const update donut quantity equals, now we're going to pass in the event object here, and we can reference that. I'll tell you what, let's just do a quick test and console log the donut quantity. So I'll say event target.value, and that's going to give us basically the user input for that text input field. So I'll say donut quantity, and let's just make sure that we're getting that value correctly before we move forward. Oops. All right, perfect. All right, so I'm going to pop open the console here so we can see that logging statement. And so it should basically update every time let me update the page. Basically, this should output a console log with every keystroke or every input. Yeah, there we go. That seems to be working just fine. Okay, great. So we can remove that console log statement. And so what we want to do here basically is set a variable byte count, which we've already determined up here, which we've already defined up here, byte count. So we're going to use the set byte count setter function. And all we have to do here is, well, I shouldn't have deleted that event target value, but there we go. So now instead of console logging, we're setting our state variable to event target value, which is the value that the user input. All right, so let's go ahead and complete our buy_donut handler function now. All right, so we talked about the two different types of function calls earlier, call and send, and we were using call earlier because we weren't actually writing any information to the blockchain, we were just reading, read-only. This time we're going to use send because by purchasing donuts, we're actually changing values and balances and things like that and writing data to the blockchain. So the first thing we need to do, we actually need to get our accounts. So again, I'm going to do const account equals await. We'll use web3.eth.get accounts. So we're using this twice in two different functions, so you could argue that maybe you could extract this somewhere a little more globally, but for now we'll just go with this. All right, so await, this is an async function, and we'll reference our local contract, so VM contract, okay, dot methods, and let's take a look at our contract again. What is our purchase? Okay, it's just called purchase, so this is the method that we're going to be calling, dot purchase. Now this time we're going to do a send, and the send function takes some arguments. So first we're going to specify from who's sending this transaction, and that's going to be accounts at 0, or account at 0. Okay. Now there's a couple of other optional parameters, and we'll just take a look at those real quick. Namely gas and gas price. So you can kind of read about these, but this is if you want to be a little bit more manual and have a little bit more control over the amount of gas you're using and the price, basically the ceiling price for the entire transaction, the gas limit. Now this takes a lot of sort of trial and error and experimentation because the conditions are always different on the blockchain, and late at night on a weekend the gas prices tend to be lower. Lower usage on the network, and so you could also just leave these, not include these at all, and basically MetaMask will estimate these values for you based on the current conditions. So let's try it and see if it'll work without specifying either of these first. So we'll just leave it at this for now. Go ahead and save your file. And let's just see if what we have so far works. So I'm going to go back to the browser, go back to our page here. Await isn't allowed in non-async. Okay, so we forgot to put I forgot to put the async keyword right here before our function. Let's try that again. All right, great. All right, so let's start out with 2 donuts here. And if we do buy, we should expect that MetaMask is going to pop open and ask us to verify the transaction. Oh, cannot read properties of undefined, reading ETH. All right, so what this is telling me basically is that Web3 is undefined here since this property lives off of Web3. See, we're doing web3.eth. So Web3 isn't available, down here in the buy donut handler. So what this is telling me basically is we just need to do a little bit of restructuring of our code because the current model sort of worked as long as we were doing get inventory handler and get my donut count handler. However, now we're trying to add another function, buy donut handler, And basically to do any of these things, we sort of need three things. We need an instance of Web3, we need an instance of our contract, and we need the list of accounts. And as I mentioned just a few minutes ago, we sort of have some duplicate code here with get accounts here and there. So I think a better strategy would be to gather all of these things in one place, which would be in the Connect Wallet handler. So we basically grab these three values, and then we should set them in React state so that they're available in any other function in the program. So I think that would be a better approach for us. So let's go ahead and do some refactoring and make that happen. So let's see, Connect Wallet handler. All right. So good, we're grabbing Web3 already. We're connecting. Once the Connect Wallet approval goes through, we're fetching window.ethereum and creating a new Web3 instance. So let's create a React variable to hold Web3 instead of using this global right here. So we'll get rid of that, and let's do const Web3, and then we'll add a set Web3. Okay, and we'll say use state, and we'll initialize that to a null value. All right, now we can actually use the setter in our Connect Wallet handler to go ahead and set that. So right underneath here, we'll do set Web3, Web3. All right, great. So just to make things a little bit clearer, let's sort of document what we're doing here each step of the way, just so it's super clear. So I'm going to say check if MetaMask is available. That's our first step here. All right. And then right here, we're requesting a wallet connect. So I'll say request wallet connect. This is the point where sort of MetaMask pops open and asks us to accept. And then set Web3 instance. Set Web3 instance. Okay. Great. Okay, so next thing we want to do, let's get a list of accounts. Current accounts that are connected through the wallet. All right, so here we're sort of going to, we can move back up a little bit here a bit, and we can just grab this statement. We're not going to need that anymore. And also the place where it's duplicated, we can get rid of that. And now that's just going to live in one place right here. Okay, so now what we can do is set the current account into a React state variable. So even though we haven't defined this yet, we're going to do that in a second. So let's say set address, and let's say accounts at 0. All right, perfect. Now let's go ahead and create that React variable. What do we say? Accounts or address? Okay, so this is going to be address, and then set address, and we'll say use state equals null. We'll just copy that from above. Okay, great. All right, so what else do we need down here? Oh, let's go ahead and set our contract instance. So we'll say create local contract copy. And let's just use a short variable name since we'll be using it so many times. Now, what we're going to have to do here, because we're really just importing the contract instance in the old model, so I think what we're going to have to do is do a bit of refactoring of our vending.js. We're going to make this a function so that we pass in Web3 and get back our contract instance. Because the other problem here is that we're using the Infura provider, and I just realized this, but this isn't actually going to work for MetaMask. So we need to pass in the MetaMask provider here instead of Infura. So let's do some refactoring. Let's first go ahead and create that variable up here. So I'm going to say const VM contract. We'll keep with the same name that we're using to make things a little bit easier. Then I'll say set VM contract. And again, I'll say useState equals null. So it'll have a null value at first. And then what we're going to do, we're going to pass in the Web3 instance. So we're going to, let's see, how's this going to work? All right, we're going to rename this a bit. So let's say vending machine contract. And again, sorry, we haven't created this yet, so not to be confusing here, but we're going to do that in a second. So let's say Web3, and then, so this will be a new function on our vending.js that we'll create in just a second. All right, so then we'll set that into state. So we'll say set VM contract and pass in the contract instance, which we're calling VM here. Okay. Now the other thing we're going to do is we're not going to call this in the callback from connect wallet handler. We're going to move this back into use effect. All right, so let's save our progress so far. All right, so the next thing we're going to do is refactor vending.js to make it a callable function to where we can pass in our Web3 instance rather than just a direct export of the instance. All right, so first we can get rid of this Infura provider. We can actually get rid of the Web3 here. And we can get rid of this. And so we'll just have our ABI, we'll keep that. And then we want to make a callable function here. So let's go right about on line 3. And what we're going to call it again, vending machine contract. Okay, let's just grab that, paste that here. Okay, so this is going to take a Web3 instance as an argument. And then we can use the code from here. We still need this, so we'll return this. So we'll say return new Web3 contract, and I'll just format this a little bit so we can see it better. All right, and we'll say export default vending machine contract. All right, perfect. So let's go ahead and save that. Let's go back to our vending machine JS file, and we'll just have to change the name here to match what we updated it to. All right, and we're importing Web3, so that's good here. All right, so we said that we were going to move get inventory handler to use effect. So this time, though, the problem is use effect is going to run as soon as the page loads, and so these variables aren't going to be ready because connect wallet handler will happen only after the user clicks on that button physically. So we need a couple of checks here. We can also move get donut count handler here. All right, and we'll add some checks. So let's do an if statement, and we just want to make sure VM contract is available before we try to invoke these functions. So we'll say VM contract, and we'll say the same thing down here. This one, get my donut handler. Yeah, this one. So this one also depends on accounts. So we actually have to check for accounts as well, which we're now calling address, right, in our React variable, in our state variable. Okay. Now the other thing is we want to basically have these run only when these values change. So we can say VM contract and address. All right, and go ahead and save that. Okay, now the other thing, we can replace this with our React state variable. So we'll say address, because since that's already set to accounts at 0. Okay. Now by donut handler. All right, so we're We need to put this in a try-catch statement first of all. So let's set that up. And on error, we just want to say set error, error.message. All right, that looks good. Now we can move our await statement inside the try. And oh, we also need to set a value, right? So since we're sending a transaction, there has to be some value set. So all right, so if you remember from our smart contract, the price of a donut is 2 Ether. Maybe we should have set this a little bit less for testing purposes, because we're going to actually have to spend 2 test Ether every time we test this. But since we've already deployed, we'll just stick with that for now. Now value needs to be defined in way, and remember that's a much smaller denomination than Ether, so it can be a bit of a pain to go out and get the value for that. So what we can do is we can leverage a utility called two-way. So then we could define the value in Ether and then call two-way. I'll show you how that works. So this is under Web3, under the utils package. I believe it's called utils. Yeah, and then two-way. And so this will be a string value. This is the value in Ether. And then we have to define the unit that we're converting from. Okay, so 2 Ether. Now, also, this is going to be 2 Ether per donut. So we can multiply that by the by count. And by count was set as right here, as a React state variable from the user input in the text input field. Okay, great. All right, I think that's looking good. We might be at a place where we can retest this. Let me just take a look here. All right, let's go ahead and save that and let's retest. So let's refresh the page. And let's make sure our wallet is disconnected. Okay, so far so good. Let's go ahead and test it and attempt to buy 1 donut. Cannot read properties of null reading methods. All right, so there's something still going on here. Methods null by donut handler VM contract. Okay, so that's referencing React state variable, and that should have been set down here. Vending machine contract web3. Oh, I just didn't connect a wallet. All right, let me do that first. Yeah, none of this works unless you connect the wallet. So let's go ahead. Okay. Now I'm still not seeing my donuts. Let's go ahead and try this. Valid number of parameters for purchase got 0, expected 1. So a bit of trial and error here to get this right. Oh, okay, so we forgot to send in the by count. Okay, so that our function knows how many donuts we want to buy. All right, let's go back. Let's try this again. All right, I'm just going to disconnect and reconnect for good measure here. It feels like we're very close to having this working, so we just a few more details to flesh out. All right, 1 donut. Account is not defined. Okay, on to the next error. So let's see. Oh yeah, we can change this to address. There's always little things like this to fix after any big refactor. So let's try that again. And I think we can just hit the buy button again without refreshing. Okay, so this is a great sign. So we've got 2 here. So our wallet is recognizing that we want to put a purchase through of 2. Let's go ahead and click confirm. And we can actually check in our wallet to see if this transaction is going through. Yep, so we've got a pending purchase. That is great news. It always takes a little bit of time for these purchases, for these send transactions to go through. There we go. So great. That is looking good. We've purchased a donut. Our ETH balance is reflecting -2 for the donut purchase and some change for the gas. Great. All right, so you know what? It'd be good to have like a success message here so that we know from a UI perspective that the operation succeeded. Let's try to refresh the page and see if vending machine inventory has incremented. All right, so maybe a little bit of work here to make sure these values get updated. All right, so in the meantime, let's go ahead and set a success message. So let's define a new React state variable for success message. Okay, and we'll initialize that to an empty string. And let's find our error HTML somewhere down here. All right, so I believe this is has text success in Bulma. I'm going to take a risk here and try it without actually referencing the docs. Success message. Let's just do a quick test. So we'll short circuit everything and just set this straight away in use effect. So I'm going to say set success message, just to make sure that we've got everything wired up here. All right, let's just see if this reflects in the UI. Yeah, okay, great. So what we can do is move this into the callback, the success callback for our byDonut function, byDonut handler, and we want to do that right underneath this await here. And how can we make this a little more user-friendly? Let's say, you know, X number of donuts successfully purchased. So we can use donut by count. Well, we could add some additional logic to make this plural or not, but let's just leave it at this for the sake of simplicity, because we got some other things to fix. So, okay, great. All right, so the next thing we wanted to fix was the get my donut count handler. This function right here. Function logic looks fine. Oh, we forgot to invoke the function, or I did. All right, that should be an easy fix. Now, the last thing that I was seeing, that once we purchased the donuts, we weren't seeing those values incremented. So let's try to add another. So let's add a React state variable that will increment every time that we purchase donuts, and then we'll use that as a dependency in use effect so that these functions get rerun, if that makes sense. So let's say, let's like keep track of the number of purchases, I guess. So we can say purchases and set purchases equals use state, and we'll initialize this to 0. All right. And then we just need to increment this basically with every successful purchase. Okay, that should do the trick. And then finally, we want to add this as a dependency to use effect so that these values get rerun. And if I'm not missing anything, then this should work and update the values with every purchase. All right, so with those improvements, let's go ahead and save the file and give it another try in the browser. So I'm going to refresh the page and kind of clear the state here. Close that tab. Okay, I'm just going to disconnect here and reconnect. All right. So hopefully once we connect, we should see at least this like set to 0 or 1. We have one donut, right? So we should see 99 and 1. Let's see how this plays out. Great. That theory tested successfully. So yeah, let's try to purchase another donut. And so the things we want to check for here, number one, we want to see our success message show up, I think right below the buy button. And then we love to see these two values changed here. So let's give that a try. Great, 2 Ether. And we have enough in our wallet. Otherwise, we'd get a sort of error message or warning saying that, you know, it doesn't look like you have enough to cover the transaction cost. So we'll go ahead and confirm that. And that's going to be pending still for a few more seconds. So we don't expect to see any update yet in the UI. And we can always check that by opening up MetaMask and looking down here at the queue. Excellent. Okay, so we got one donut purchased. The only thing is I'm not seeing our state variables incremented here like I was hoping. So let me think about what we could do to fix that. So let me just try to refresh the page just for fun to see if that's going to make any difference. Okay, so that's going to basically that's resetting us to like a pre-connect wallet state. Oh, okay, and as soon as we click on connect wallet, then we get the incremented values. Interesting. Okay, let me think about that for a second, and we'll hopefully make one final fix to trigger this, you know, right exactly after the buy. All right, so looking at the code, I think I'm just handling this update wrong. So set purchases is a function, and I'm just trying to increment a function, so that's not going to work. Basically, what I need to do is set it to purchases and then increment that. And is that purchase or purchases? I forgot. Purchases. Oops, yeah. Yeah, I think that looks correct. So let's try this. Try this one more time. All right, I'm going to refresh the page. I'm going to reconnect the wallet. Oh, and unfortunately we don't have enough. All right, you know what? I'm going to have to pause the video and restock the Ether a bit because we don't even have enough to buy a donut now. See, that's why I should have made the donut price a little bit lower for testing purposes, but oh well. All right, I've restocked my wallet with a few more Ether, so we are ready to test again. Okay, connect. All right, great. So we're seeing the accurate count state of things. And I'm going to try to purchase one donut. Okay, looking good here. Go ahead and confirm that. And we'll open MetaMask back up so we can monitor that transaction. Okay, so something's not working right in our program to where these values aren't getting incremented. They do when I click on Connect Wallet, however. So you know what? I think I just need to trigger these manually. Let's try that. All right, so I'm going to sort of roll back these changes I just made. I'm going to copy these two statements, and this may not be the most elegant way to do it, but meaning that I could probably create a new function to call these, but let's just do it this way for now. And then yeah, let's just try this. Oh yeah, let's remove this for now. All right, so now we're directly calling these methods. Let's just run this test again and see if this works any better for us. This might be the way to go. All right, and so I'm still connected. Let me just try to buy another one. Let's see if we can get this to work properly. Confirm. All right, I've got a good personal supply of donuts now. I'm not going to go hungry today. Excellent. That's what I was looking for. All right, so everything updated in real time. We've got our success message. We purchased our donut. Everything is looking good. All right, guys. Well, I think this is where we're going to end for today. This video went way longer than I thought it was going to be originally, but I think that's okay. We went through the entire process of creating a Web3 application from a blank slate to a working Web3 application on Ethereum Rinkeby testnet. We went through the steps of deploying our contract. We reused the contract from one of my previous tutorials just to save a little bit of time there. And again, if you want to go through the details of that contract line by line, I definitely recommend that you take a look at that video again. By the way, one thing I was sort of noticing as I was going through testing is that there's a flaw in the vending machine contract. Maybe not a flaw per se, but the problem is that as people are purchasing donuts, there's really no way for the owner to get the money out of the contract as it stands right now. Like we're not forwarding the balance to anybody or anything like that. So I'll leave that as an open question to you guys. How would you handle that if you were the contract owner? How would you go about getting those funds out of the vending machine contract and into your own wallet as the owner? All right, guys, that's all I've got for today. So hope you enjoyed it. If you enjoy the content on this channel, please consider subscribing. And I hope to see you in the next one. All right, take care. Bye.